Okay, in section 10.4, we're going to talk about what an inscribed angle is. We've already talked about what a central angle is. And a central angle has its vertex at the center of the circle. An inscribed angle has its vertex on the circle. So here is the angle that I'm talking about right here. We have one side of the angle and then it changes directions. So we're talking about this angle right here being the inscribed angle. The vertex of the angle is on the outside of the circle. Okay? The sides of that inscribed angle are chords. Okay, we talked about a chord having its two endpoints on the circle. So these are both chords. And then we consider this piece out here to be the intercepted arc. Now remember, with a central angle, the degree measure of the angle was the same as the arc on the circle. Those were equal. But with an inscribed angle, it's different. Okay, you look down here, it says the measure of the inscribed angle is half the measure of the intercepted arc. So if the arc is out here is 80 degrees, that's out on the circle, then down here the angle itself that's inscribed, that's on, the vertex is on the circle, is half of that. So if this is 80 degrees, the angle down here would be 40 degrees. Or if I give you the angle, the inscribed angle, you could double it to get the intercepted arc. Okay, some of your drawings are going to get a little more complicated. It says two inscribed angles that intercept the same arc are congruent. So here's one inscribed angle. Okay, there's one angle, and you can see that it intercepts the arc starting here and ending there. Okay, that's 80 degrees. Okay, well, we got a second angle here that's inscribed. Okay, this inscribed angle also has the same beginning and the same endpoint. So they share the same arc. They intercept the same arc. That makes these two angles congruent to each other, is what that says. And again, you would just know that the angle measures half of the arc, and since they both share the same arc, taking half of the arc would produce the same angle measure. Okay, turn your page. Okay, got a few other things here. It says an angle inscribed in a semicircle is a right angle because it intercepts the opposite semicircle. Okay, for example, if I have this inscribed angle here, okay, well, here's the arc. It's starting here, it's going all the way around, and it's ending here. That arc is 180 degrees. So if you just followed the rule on the previous page, the angle measure is half of what the arc is. So if the arc is 180, if I divide that by 2, I end up with a 90-degree angle. So anytime an intercepted angle intercepts a semicircle, it's going to be a right angle or 90 degrees. It says if a quadrilateral is inscribed in a circle, each pair of opposite angles in the quadrilateral is supplementary. So if I have, let's say you've got 4 angles in, okay, what it's saying is that the opposite angles are going to be supplementary to each other. That's a word from first semester. To be supplementary means that they're going to add up to 180 degrees. So angle 1 and angle 2, they're opposite of each other. Angle 1 plus angle 2 is going to equal 180 degrees. I'm sorry, not 2, 3. And angle 2 and angle 4 are opposite of each other. So they're just saying that 2 plus 4, they're going to equal 180 degrees. That's if a quadrilateral is inside the circle. Okay, the last drawing that we're going to look at here. We have a quadrilateral inside of a circle. So can I pick out all the different letters? I got quite a few. I got an A, B, C, D, and E to find. Okay, we can start by looking at opposites here. I know that these two angles are going to be supplementary of each other. So 102 plus angle C has to equal 180. So that means angle C is going to be 78 degrees if I subtract 1 and 2 from both sides. So C, put that in my drawing, that's 78. Okay, another thing I can do is using that 78, I've got an arc here that's got the vertex at 78. Okay, so if that angle is 78 degrees, then what do I know about this arc? What do I know about that arc? Well, the arc is twice as big as the angle measured. So if it's 78 degrees and I take that times 2, this whole arc should be 156 degrees, but part of it's 88. The other part is A. So if I took 156 and subtracted the 88, I'd get 68 degrees for A. Okay, so now I know that this is 68 degrees, and I still know that that's 78 degrees. Okay, I got a few more to find. Let's see, what should I do next? I could look at this. That's an inscribed angle right there. Here's the angle measured. That means the arc that starts here and goes all the way around to here, that should be twice as big, so that should be 204. If I take 102 and I double it, I get 204. This much of it is 94 degrees. So if I subtract that, I get 110 for D. Okay, so 68, 110, I'm going to get rid of that. So this is 68, this is 110, and this was 78. If I want to find E next, here's the inscribed angle. Okay, it is intercepting this arc that goes all the way around. So if I add those two up, I get 178 degrees. Well, I know that the inscribed angle is half of that measure. So if I divide it by 2, I would get 89 degrees. And then I know that these two are supplementary. So B plus 89 is equal to 180. Subtract 89 from both sides, and B is equal to 91 degrees. And I've found all the measures that I need. Okay? Go ahead and give that worksheet 10-4 a chance.